The pistol shrimp, also known as the snapping shrimp, is one of the most remarkable creatures in the ocean. This tiny marine crustacean, usually only about 1 to 2 inches long, possesses an incredible weapon. One of its claws is specially modified to produce a powerful snapping action that creates shockwaves, bubbles, and heat intense enough to stun or even kill prey. Here's a deeper look into the fascinating world of the pistol shrimp, whose unique adaptations have captured the attention of scientists and ocean enthusiasts alike. The pistol shrimp's distinctive feature is its asymmetrical claws, where one is considerably larger and functions as a literal pistol. This claw isn't used to pinch or hold, like many other crustaceans. Instead, it's a sophisticated tool that can be cocked and fired. When the shrimp snaps this claw shut, it generates an intense burst of energy, creating what's known as cavitation bubbles. These bubbles collapse almost instantaneously, releasing an incredibly powerful shockwave along with a loud sound, one of the loudest sounds in the ocean, even though the shrimp itself is tiny. This snapping sound can reach over 200 decibels, louder than a gunshot, and can be heard underwater up to several kilometers away. This phenomenon has earned the pistol shrimp its reputation as one wave created by the pistol shrimp is powerful enough to stun or even kill small fish and other prey. When the claw snaps shut, it creates a high-speed jet of water that moves so rapidly it causes the surrounding water to vaporize into bubbles due to a phenomenon called cavitation. These bubbles then collapse with an incredible force, producing both heat and light. Temperatures inside these bubbles can reach nearly 8,000 degrees Fahrenheit, almost as hot as the surface of the sun, though only for a fraction of a second. While this extreme heat doesn't persist long enough to affect the shrimp's surroundings, it's a fascinating display of the shrimp's lethal weaponry. The light produced by the collapse is known as sonoluminescence and, while not visible to the naked eye, is a rare example of an animal producing light without traditional bioluminescence. The snapping claw is a marvel of natural engineering, specifically adapted for both hunting and defense. Pistol shrimp use this claw to hunt small fish, crabs, and other crustaceans by stunning them with the shockwave, making them easy to capture and consume. They are ambush predators, waiting patiently until their prey gets close enough, then snapping their claw to incapacitate it. In addition to hunting, the snapping claw is a powerful defense mechanism. If a predator approaches, the pistol shrimp can unleash its sonic blast to create confusion and disorientation, allowing it to escape. This feature is essential in the crowded, often competitive environments where pistol shrimp live, such as coral reefs and underwater rock formations, where many species compete for food and space. There are more than 600 species of pistol shrimp, found in warm, shallow waters around the world, from tropical coral reefs to muddy estuaries. Despite their small size, pistol shrimp often have a big impact on their ecosystem. They tend to live in burrows, which they either dig themselves or take over from other creatures. These burrows serve as both shelter and a vantage point from which to ambush prey. In some species, particularly those living in sandy or muddy areas, pistol shrimp are highly territorial and will aggressively defend their burrow from intruders, using their snapping claw as a deterrent. These burrows also help aerate the sediment, creating a more hospitable environment for other small organisms by increasing oxygen levels in the soil. One of the most interesting aspects of the pistol shrimp is its symbiotic relationship with certain species of gobies, small fish that share the shrimp's burrow. In this partnership, the pistol shrimp and goby work together in a mutually beneficial arrangement. The goby acts as a lookout for the pistol shrimp, which has poor eyesight and is vulnerable to predators while outside its burrow. In return, the shrimp provides the goby with a safe place to live. The goby remains close to the shrimp, often touching the shrimp with its tail to signal when it's safe to come out and when it's time to retreat back into the burrow. This symbiosis is a remarkable example of cooperation between species, where both the shrimp and goby benefit from each other's presence and contribute to each other's survival. The snapping mechanism of the pistol shrimp's claw is a fascinating adaptation and one that scientists have studied closely. The shrimp's claw functions somewhat like a spring-loaded hammer. It has a joint that can be cocked back and then released with a sudden snap, creating the powerful jet of water. This snapping action is so fast that it occurs within microseconds, a testament to the shrimp's specialized muscle structure and incredible coordination. The claw itself consists of two main parts, a hammer-like structure that strikes an immobile part of the claw, creating the cavitation bubble that leads to the powerful snap. What's truly amazing is that if a pistol shrimp loses its snapping claw, it can regenerate it over time, ensuring it retains its essential weapon for both hunting and defense. In addition to their unique anatomy and behavior, pistol shrimp are known to exhibit complex social behaviors, especially within certain colonies. Some species are highly territorial and will engage in snap-offs, where two shrimp face each other and repeatedly snap their claws, producing a sound that serves as a show of strength or a warning to back off. These snap-offs are often enough to settle disputes without any actual physical fighting, demonstrating that the shrimp's sound is as much a communication tool as it is a weapon. In these colonies, shrimp also often assist each other in burrow maintenance, showing an unusual degree of social organization for crustaceans. Despite their tiny size, pistol shrimp are so loud that they can interfere with sonar and underwater communication systems. In areas where large colonies of pistol shrimp live, the collective snapping can create a constant background noise underwater, which can be detected by sonar equipment from ships and submarines. This phenomenon is particularly common in tropical coral reefs, where the continuous snapping of thousands of shrimp creates what is sometimes called shrimp noise or reef crackle. This collective snapping noise can be so loud that it masks the sounds of other marine animals and has even been known to interfere with naval sonar operations, leading the pistol shrimp to be both a marvel of nature and an unintentional challenge for technology. In summary, the pistol shrimp is an extraordinary example of evolution's ingenuity. With its high-speed snapping claw, capable of producing shockwaves, light, and even extreme heat, the pistol shrimp has developed a hunting and defense mechanism that's almost unmatched in the animal kingdom. Its ability to modify its environment, form symbiotic relationships with gobies, and its highly effective territorial behavior all contribute to its reputation as one of the ocean's most interesting and powerful creatures relative to its size. The pistol shrimp not only exemplifies the adaptations necessary for survival in competitive marine environments, but also reveals the unexpected complexities of small marine life, which often goes unnoticed beneath the ocean's surface. Please give this video a thumbs up, leave your comments down below, and subscribe to the channel. See you in the next video. 4-0